recently released the building footprint dataset from almost all around the globe. In this video, I'm going to show you how to download that building footprint dataset in your required format, either in Shapefile or GeoJSON, with your custom area of interest. So let's get started. In order to download the dataset, you need to go to site.research.google/openbuildings and you will enter into this website. So don't worry about this URL. You can find that URL in the video description below. And here they have some description about dataset. So they mention they have 1.8 billion building detection from 58 million kilometer square within Africa, South Africa, Southeast Asia, and Latin America and Caribbean. You can see the dataset in this map. So they have mostly covered the southern part of the globe, and then they have the building density shown in the map. And then this dataset can be used in population mapping, humanitarian response, environment science addressing system, and vaccination planning, and also in the statistical indicator. So in order to download this dataset, so you can see all the license and then dataset creation things. So they have two type of license, so Creative Commons Attribute CC by BFO license, and also Common Open Dataset license. So in order to use the dataset, you don't need to pay, or you don't need to do anything. You can just use it. Since it's the open source data. They have discussed about the data accuracy in terms of three types: low density, medium density, and high density. So you can see the accuracy scores, precision versus recall value in this graph for Africa, Southeast Asia, and then Central America, Caribbean islands. And yeah, so by default they are giving the data set in the CSV format with the threshold score, but of course you can download this data set as the CSV and Shapefile and GeoJSON format later with the help of Python. Don't worry about it, I'm going to show you how to do that. So in order to download the dataset, you need to go to the almost bottom of the website, and you will see the link is download from the map, and then there they have the tiles, and based on if you click the any of these tiles, you can actually download the dataset for that tile. For example, if I want to download the dataset from Indonesia, near Jakarta, then I can click on this link, and then simply click on this link. It will actually start downloading, and then your data will be downloaded. So in order to demonstrate these things, so I have downloaded the three dataset. One is from this Indonesia Jakarta, which is 22 MB size, and another dataset I downloaded from the somewhere near India, so which is around 3 GB, and another dataset is around 8.4 GB. So I'm going to show you how to deal with this big amount of data, and then how to convert that to the reasonable size in the Shapefile and GeoJSON file. Alright, as I said before, I have downloaded the three files. One is around 20.6 MB, another one is around 1 GB, and another one is really huge file. It's around 8 GB. And here I already extract these files. So first of all, I want to show you this one, so which is the smallest size. If I try to extract this, it's 56 MB, and then this 56 MB dataset, I think we can open it in the Excel sheet and then try to visualize it slowly. But for the other dataset, like the huge amount of dataset, several GB dataset, you cannot open it in the CSV file and you cannot even see the file. So here, if I show you this latitude, longitude means the building centroid, latitude and longitude coordinate, and then area in meters mean the building footprint area, and then this is the confident score. That means if the accuracy is higher, near to 1, that's actually the perfect matching of the building. If the accuracy is low, that means it might not be building, and there is no guarantee. And there is like geometry attribute. Here you, this is the actual polygon size, and I'm not sure about this full plus code attribute, but anyway, so we have the data which have 5 attributes: latitude, longitude, area, confident, geometry. I think 1 2 3 4 5 6 attributes. So what I'm going to do is I'm going to convert these CSV files into the geojson or Shapefile, and then try to load it in QGIS or whatever visualization platform we have. In order to create the Shapefile, I'm going to use the Python. So I'll write, first of all, I'll uh, create the file is buildingfootprint.ipynb. If you are not familiar about this file format, make sure you watch my some of the previous data science related content, which are might be in the description below. So make sure you are familiar with this Python notebook. And here I'm going to use the GeoPandas in order to convert this building footprint CSV file to the Shapefile. So if you don't know, make sure you watch my crash course on GeoPandas for absolutely beginner, which is also in the description below. And since I already installed my GeoPandas package, so first of all, I want to import pandas as PD, and then maybe GeoPandas as GPD, and then hit run. So I have to select the Python kernel. Uh, Sorry, I selected the wrong kernel. So it should be GDAL one. Python environment and then GDAL. So this is my virtual environment. If you are not familiar about this virtual environment and GeoPandas, make sure you watch my crash course on GeoPandas. So I hit run with the GDAL environment, and now it will run, and then I can use this package. All right, now my GeoPandas is loaded successfully. Now I can create the data frame. So with the pandas first, and then I can provide the data link over here. So in order to provide the data link, so I can switch back to my file, and then copy the file location, file path, and then write it here. So, and then if I say df.head, then it will print out the first five row of this CSV file. All right, now we need to convert this data frame to the geo data frame. In order to convert that, so I'm going to write like GDP and then gpd.geoDataFrame, and data frame will be df, which is the above one, and then geometry will be the sorry, this is not my geometry. Actually, geometry will be the geometry column, and my CRS will be the CRS will be the 4326, which means WGS 1984 coordinate system. And then if I write gdf.head, then everything will be same, but this is actually the geodata frame with the coordinate system is WGS 1984. And then here, if I write gdf.toFile, and then I can write it as a CSV, I mean Shapefile. And now my location is inside download 687 buildings and 687 buildings.shv file. Now hit run. So Okay, so now it give me the warning, but don't worry about it warning. So what it will do is if the column name is longer than 10 character, then it will truncate to 10 character, since that's the property of the shape file. And it will take a minute, and you'll see the shape file over here in this directory. And in a minute, I'm going to load that shape file in the QGIS or whatever system we have. All right, now my output is generated. So if I show you in QGIS, so it will automatically align with my base map. And since this is my first area from Indonesia, so you can see my building footprint like this. So this might not be like exactly fit with the OSM building footprint. I don't know which file have the error, but it might be due to like little bit shift in the training imagery dataset, but that's how you convert it to the shape file. And I have also like tried to generate the shape file from another file, which is 39F, I think. So it's around like, not this one, 30F. So it's around like 2.5 GB. So about like size of data, so you can easily generate the shapefile or geojson file using this geopandas method. But in order to like deal with this high, I mean the 20 GB of CSV file, you need to use the DAX. So the geo in this video I'm going to show you how to use the geopandas dax function to like load the 20 GB of CSV file and then clip it into your area of interest. So yeah, so in order to do that, so you need to like install the GeoPandas DAX package. So here I have already installed with this command line. So conda install -c conda for dask GeoPandas. So if you have the anaconda environment, since I have the GDAL as the anaconda environment, so I already installed this package. So now I can import it and then use it as like is my model. So okay, let me zoom in a little bit so that you can see it properly. So here now I'm going to import the dask.data frame as dd, and also I'm going to import the geopandas dax. Sorry, it's dax geopandas. Okay, and then not data, it should be dask, and then hit enter. So now my dax model is already imported. Now I need to like create the dax data frame, which is represented by ddf normally. So I can read the csv file from, sorry, from this location, but not from this location. So I can copy the location path and then paste it over here. Okay, so now if I say ddf.head, so you will see the exactly similar output. uh, it's simply the dax data frame. What it will do is it will not consume the memory, too much memory to render it, and then it's helpful to like solve the memory issue. And now I need to like convert it to the geo geo data frame, since it's the normal data frame. So in order to convert that to the geo data frame, I can write gddf equal to dax geo data frame dot from dax data frame, and then my data frame name is ddf, and of course we need geometry column. And for the geometry column, this time it will be ddf and then geometry. And also I need to like map it dot map map partitions, and then it should be mapped from gpd.geoseries. All right, this is my geodata frame, DAX geodata frame, and I also want to like reset it index, gddf dot reset index, and I don't need drop equal to true. And if you write the gddf dot head, it should be the same, like similar things. All right, so now it's time to like create the area of interest. So in order to like create area of interest, so you can go to geojson.io website, and here you can like create your own boundaries. Make sure that boundary fall under the building dataset link. So here, if I zoom in to this particular location, so maybe you can choose any one of area, but I think for this particular task I'm going to like download the dataset from some place of Kathmandu. So simply make the rectangle or whatever shape you have, or simply make available that file in the Shapefile format, so that we can easily import it in the geodata frame and then load it. So here I can save it as the Shapefile, and then I can get start with that one. But for me, since I already have the data set over here, so this polygon.ssp, so if I show you this polygon, so it's the, I think, same as this polygon below. So zoom to here. Yeah, so this is the right, this shape from the build Kathmandu city. So now I'm going to clip my data set into this particular polygon shape. So in order to do that, so I can write the AOI equal to gpd.read file, and then location to that particular zip file. All right, so here copy path, and again I need to go here, and then I can check aoi.head, and then it will be simply the polygon, right? So if I type the aoi.crs, so it will be the WGS 1984, which is EPSG 4326, right? So I can set my this geodata frame with the same coordinate system. So here I can write gddf.crs. So if I simply run it, there is nothing, but I can assign it with the aoi.crs. So it will automatically take the AOI coordinate system is the GDDF coordinate system. So right now I have the 4326 coordinate system from my geodata frame from this 20 GB of CSV file. So here now what I can do is I can write the clip, and then I can like clip the DAX geopandas, and then dot clip, and then I can write which feature I want to clip, and then which area of interest. And if I say clip dot head, then I'll see the exactly similar output, but this time the buildings are only from this particular area of interest. All right, so now it's time to like export this clipped file as the zip file. So in order to do that, so I can write clip dot to file, and then I can provide the location where I want to save this file. And for now I can like provide this link as the link to save this data set, and then I can write AOI buildings.shp, right? Sorry, it should be shp. Okay, so if I do so, it will automatically like clip my save file. But yeah, before doing that, so I need to like compute this clipped file, because it's the DAX geodata frame, so it cannot be like exported as the simply by the to file method. So if I run this, I'll get the error here. Data frame object has no attribute to file, right? So in order to like make it workable, so you have to like do clip equal to clip.compute, and then you need to provide clip.to file and then the file location. So if I run it, it will run, but since this is the 20 GB of data and it has lots of computation, actually I already run this function. It took me around 15 minutes to run this function, but it's really depend on your data size and your area of interest. So since I already run, so I'm going to cancel this and then show you the result, because I already run it in the different environment and then the code is exactly the same. Okay, here, so if I show you the result, so it's in the download folder, and then it's the AOI footprint, and then if I load it here, so this is my area of interest and these are the like buildings. So yeah, that's how we like download the exact required footprint. There is like no limitation. We can load whatever file of data we have. Let's say for me it's the actual size of data was around 20 GB. So yeah, that's the really good way to like load the data. So this is the 2 MB one, and then actually this one is the 20.2 GB CSV file, right? So yeah, in this way you can simply like download the building footprint from almost all around the world, only on the southern part from this Google dataset. I hope you enjoy this video. If you enjoyed it, please hit the like button and subscribe to my channel. Thank you for watching.